Have you ever wondered how the vast ocean could be used as an energy source? My name is David Jun, and today I'll be presenting about the answer to this question, ocean thermal energy conversion. Ocean thermal energy conversion is a process that takes advantage of the temperature difference between the surface of the water and the bottoms of the water, where a kilometer down below the surface, the cold water temperature varies drastically from the surface. The thermal energy from the naturally heated water is converted to usable electrical energy using a cyclic heat engine. You can think of the influx of the heat as a warm surface water and cold water as a heat sink. The Carnot efficiency actually is pretty low. It's about 6 to 8% for OTEC to be viable. This is because heat engines are proliferate when the temperature difference between the hot and the cold is high. But since the water is naturally heated and is of the same body, the temperature difference gets up to only like 20 to 30 degrees. And these temperatures are viable only in the tropic regions for an OTEC plant to be economically feasible. There are 3 different types of OTEC I would like to go over. Okay. Warm sea surface water is pumped to the evaporator, where a low boiling point fluid, such as ammonia, it expands as gas in the turbine and generates electricity. The fluid then is condensed by the cold seawater that is pumped and is recycled continuously to generate electricity. Another type of OTEC is the open cycle, where the warm surface seawater enters again, but this time without the boiling point, the low boiling point fluid. It just directly operates a turbine in a low pressure evaporator and is condensed when it meets the temperature from the cold seawater and discharges as fresh water, since the salt content is left behind in the evaporator. And the rest that is not evaporated and the cold seawater is mixed and is discharged as a mixed discharge. This will become important later on as I talk about the benefits of the byproducts. The last cycle I want to mention is the hybrid cycle, where the warm sea surface water is again pumped. But this time it's flash evaporated in a vacuum tank and becomes a steam, where the steam boils the low boiling point fluid, ammonia, and that ammonia generates electricity. And the rest of the steam goes into a flash chamber, where it's condensed by the same cold seawater that condenses both the working fluid and the seawater, where this working fluid is recycled back to generate electricity and the steam is produced as freshwater discharge. There are multiple benefits other than energy production in OTEC. First one to mention is agriculture. Community near OTEC plant can have water pipes going below the soils, where temperate climate vegetation can be produced by the chilling of the soil when the cool water passes through those pipes and chills the soils. This is beneficial because this provides diversity and resource to the local culture. And another cool benefit to OTEC is the aquaculture, where the mixed discharge of seawater is actually 20 to 40 times more nutrient rich than the surface water, and therefore we can cultivate and culture sea delicacies such as lobsters and salmons separately in an aqua farm that is more nutrient rich. And lastly, freshwater discharge. Theoretically, in 2 megawatts of OTEC power plant, it can produce about 14,000 cubic feet or 4,300 meters of cubic water each day, and that's a lot of desalinated water that could be used as a drinking source or any other source that needs fresh water. However, since OTEC is still a technology that is under research, there are a lot of challenges to it. First challenge is the economical size of a renewable plant is so big that private sector firms are still unwilling to invest in a OTEC plant unless there's a government subsidy with it. However, since renewable plants provide more energy and more savings later on in the life. It can be taken apart and NPV will pay back in the periods to come. Another challenge is that there are limited space available for land-based OTEC sites where the deep oceans are close enough for the OTEC plants to be feasible, and just like physically limits placements of OTEC plants around the globe. However, OTEC is an important technology to consider because the global warming of seas is an ongoing issue, and I mentioned this before in a separate forum where it's actually killing 20% of coral reefs that's like used as a main food source and is the bottom of the food chain. And OTEC provides a practical solution where it uses the currently unused cold bottoms of the seawater, which could serve as a large heat sink. Yeah, that's all. Thank you for listening. I'll open up the floor to questions.
Could you explain the difference again between the open and closed cycles?
Yeah, sure. So the main difference lies between the working fluid. Closed cycle uses ammonia to generate turbine, while the open cycle uses directly seawater as an evaporated gas, and that expands the turbine to generate water.
Do you know of any examples around the world where this is currently like in practice?
Yeah, there are not that many. The one that's like mainly operational is in Japan. It was done with collaboration with the Sega University and another company. It's actually pretty small. It's like 50 kilowatt generator. It's made so that it proves the theory of OTEC and provides other experimental sources for it. And there are like other multiple projects that's funded by other companies that's going to be in process in coming years. Yes.
Like economically, is it a possible thing to do, or is it like too expensive, or like what's the thing from stopping it to go to like a lot of other coastal cities?
It is an economically challenging project since you need such a big and deep pipe down to the cold seawater bottoms, and you always have to pump. And the current efficiency, like I told you, is only 6 to 8%. So if the temperature differences are not high enough, it just becomes infeasible. And there's only like certain parts of the area of the world that has the temperature difference that's viable enough to have these plants.
So environmentally, what could go really wrong?
If you have too many of these, this can manipulate the temperature of seawater because you can discharge the cold water at places you would want it to. And if you discharge too much of cold seawater into the warm sea surface water, the eco-life in that system might experience a lot of difference in temperature and suffer from it. Likewise, if we put too much of the heat back into the cold bottom of the oceans, which is less much so because the bottom of the ocean is so much bigger than surface, it could still change the salt content and life beneath.